Hello students, so we are doing Goa Board Prelim 2024 solution. Okay, so now we will be solving questions from application of derivatives. First question is the radius of a circle is increasing at the rate of 3 cm per second. Find the rate at which the area of the circle is increasing when the radius is 10 cm. So first you have to write what is given. Okay. Radius of a circle is increasing at the rate. So if the radius is r, then the radius is increasing at the rate that is dr by dt. Its derivative with respect to time is 3 centimeter per second. Okay, we have to find the rate at which the area of the circle is increasing when the radius is 10 centimeters. So radius is given and you have to find the area which is increasing area. So it is changing, right? So derivative area is pi r square. So dA by dt is 2 pi r and the derivative of r with respect to t. So this is dr by dt is 3. This is 6 pi r. Now we have to find at r equal to 10. So putting value of r 10. So this becomes 65. Okay. So this is 65 centimeter square per second. Okay. 12th one. A wire of length 28 meter is to be cut into two pieces. One of the pieces is to be made into square and the other into a circle. What should be the length of the two pieces so that the combined area of the square and the circle is minimum? Okay. So here a wire of length 28 meter is given. So 28 meter long wire is given. Okay. It is cut into two pieces. One of the pieces is made into a square. So this is made into a square and this is made into a circle. Okay. So this piece, if I consider, let it be x. This length will be what? 28 minus x. Correct? So x, we are making it into a square. Means this length, we are taking it as a square. So x will be divided into 4 parts so that they join and become a square. Correct? So side of the square becomes x upon 4. Okay. Here the length we are taking and making it into a circle. Means we have a length of a circle, that is circumference. So circumference is 2 pi r, which is equal to 28 minus x. So from this the radius is 28 minus x upon 2 pi. Okay, now we have the side of the square and also radius of the circle. Okay, we have to find what should be the length of the two pieces so that the combined area of the square and the circle is minimum. So combined area. So you have to find the area of a square and a circle. Okay. So here area of square will be side square, which is x square by 16, and area of circle is pi r square. So pi into 28 minus x the whole square upon 2 pi square. So 4 pi square. Okay. Total area is x square upon 16 plus 28 minus x the whole square upon 4 pi. Okay. Now we have to find the combined area of the square and the circle is minimum. That condition you have to. So you have to derivate this area. Okay. So to minimize dt by dx, then we have to put it equal to 0, right? And we have to find the values of x. So that x becomes your length, the value of this will get, so that the area is minimum. So derivating with respect to x, this will be 2x upon 16 plus 2 into 28 minus x, 4 pi is constant, into derivative of minus x, which is minus 1. Okay. This is 8. Okay. So putting this dt by dx equal to 0, will get cross multiplying pi x plus minus 1, so this becomes x minus 28. 8 into x minus 28 equal to 8 into 2. So 16, which gets multiplied with 0. Okay. So this is pi x plus 8x minus, here we can it is a 4. This is 2 pi into x, so 2 pi x. 64, 24. Okay, dividing by 2. Whole equation you have to divide by 2. So from this x, pi plus 4. So x is equal to 112 divided by pi plus 4. Correct? So we got the value of x. Now you have to find d square by dt. Okay, double derivating. And then we have to see whether it is greater than 0 or less than 0. Okay. At this point. So derivating again this thing. So our dt by dx, I'll write it again, x by 8 plus x minus 28 upon 2 pi. Okay. So d square by dt is 1 by 8 plus 1 upon 2 pi. Okay. So this will be, obviously both are positive, so this is greater than 0. Okay. So we have here x. What will be our other length? That is 28 minus x. 28 minus 112 upon pi plus 4. Okay. So the length of the two pieces, so that the combined area of the square and the circle is minimum, is this. This is the length of a square and this is the length of a circle. Okay, when the combined area is minimum. Okay. Next question is, you have to find the intervals on which the function is increasing, strictly increasing, and question. strictly increasing, strictly decreasing. Both the intervals you have to find. Okay. The question is fx equal to, this is a OR question, x minus 2 the whole square. Okay. So to find strictly increasing, strictly decreasing, increasing, decreasing, yeah. So start by derivating this. So differentiate with respect to x. Suppose this is equal to y. So dy by dx is 2 x minus 2. Okay. Then you have to write the derivative of this. This when you take inside it will be x square minus 2x, right? So derivative of x square is 2x and derivative of minus 2x is minus 2. Okay. So you can take here 2 common. So it will be 4 into x minus 2 into x minus 1. Okay. So dy by dx equal to 0. You will get the values of x. X is equal to 0, x is equal to 2 and x is equal to 1. Okay. Now you have to draw the number line 0, 1 and 2. Okay. So we have to find the intervals. So if you take from, so this will be your minus infinity, this will be your plus infinity, right? So from minus infinity to 0, we have to check whether the function is positive or negative. Okay. So here we have to put dy by dx, we have to see. Okay. So when you put say 0 is there, no? Less than 0, you take minus 1. If you put here minus 1, this will be negative, minus, minus, minus 1, minus 1, again minus. So minus into minus plus, plus into minus, minus. So this here it is negative. Then greater than 0. So take 0.5 plus negative, negative. So negative into negative, positive. So this will be positive. You have to just put the values and see. Okay, greater than 1, say 1.5. Positive. 1.5 minus 2, it will be negative. 1.5 minus 1, it will be positive. So this is positive, negative, positive, negative. Then greater than 2, say 3. 3 positive, 3 minus 2 positive, 3 minus 1 positive. So this will be positive. So here from minus infinity to 0 and 1 to 2. Okay, these two intervals it is negative. So it is decreasing. For 0 to 1 and 2 to infinity, this intervals it is increasing. Okay. So here we have to find strictly decreasing and strictly increasing, right? So strictly decreasing means what? When your f dash of x is less than 0. Okay. When we put values from minus infinity to 0 in f dash of x, that is dy by dx, we get answer less than 0. This is your strictly decreasing and only decreasing. So we write this as minus infinity to 0. Correct? When it is only decreasing, Okay, there is no strictly. Then it is f dash of x less than or equal to 0. That time this is, you have to include the point where f dash of x becomes 0. Okay, so we have to take this point in. So this becomes closed interval. Okay. Similarly, for strictly decreasing, increasing, have f dash of x greater than 0. Okay, so we don't take, this is union 1 comma. So this will be 0 to 1 union 2 comma infinity. For only increasing, it is greater than or equal to 0. So this becomes from 0 to 1. Both are there. Okay, like this it is. Hmm. So I'll just link the videos which I have done on strictly increasing and decreasing in the description box. Okay, you can refer them for the concept. Next question is question 13. Question 13 is from indefinite integrals. Okay, so the integral we have to find the value. Dx. Okay, so this is in the form x square, that is a square plus 2ab plus b square, correct? So our a square is x square and b square is 4. So b is 2. So we can write this as 1 upon x plus 2 the whole square dx. Okay. So there is no formula which involves x plus a the whole square, 1 upon x plus a the whole square. So we can put this x plus 2 as t. By substitution you can do this. So differentiating both the sides, you will get to dx equal to dt. So substitution will be integral dt upon t square. Okay. So this will be t raised to minus 2 dt. So integrating you will get t raised to minus 2 plus 1 minus 2 plus 1. So this is t raised to minus 1 upon minus 1 plus c. So this is minus 1 upon t plus c. Okay. Then you have to put the value of t, that is x plus 2 plus c. So D is the answer. Let's solve question 14. Next question is evaluate integral 1 upon x plus x log x dx. Okay. This also we have solved many times. So you have to take here x common. Okay. So this will be, so here 1 upon x is there and here 1 plus log x is there. So if you take, substitute 1 plus log x as t, then the derivative of this is 1 upon x dx equal to dt. Okay. Now we can substitute it here. So it will be integral dx upon t, dt upon t. Okay. So this is log t plus c. So putting the value of t, 1 plus log x plus c. Okay. Next question, question 15. How to evaluate integral x e raised to x dx. These are just 1 mark questions, okay? Integral x e raised to x dx. So looking at this question only, you'll understand that this is from integration by parts, okay? So integral uv is u integral v minus integral u dash integral v dx, okay? This is integration by parts. So u and v, first function, second function you have to choose by the rule LIATE is the exponential. So exponential comes second. This is your first, this is second. So u is x, v is e raised to x. So using integration by parts, x integral of e raised to x dx minus integral of derivative of u integral of e raised to x dx. Okay, so integral is same. Derivative of x dash is 1. This is e raised to x is e raised to x. So this becomes x e raised to x minus e raised to x plus c. Next question. Evaluate integral 1 upon cos x plus sin 2x dx. Okay, this is a 5 marks questions. So this is little bit lengthy. Cos of x plus sin 2x dx. So looking at sin 2x, you'll understand that you have to substitute sin 2x as 2 sin x into cos x. Okay, using the trigonometric identities. So cos of x you can take common. Now you have to multiply by cos of x in the numerator and in the denominator. Okay, this we are doing to get certain denominator such that we can integrate further. Okay, so this is cos of x dx and upon this is cos square x 1 plus 2 sin x. We can write this cos square x as 1 minus sin square x, correct? Okay, so the denominator, now you can see that this full is in the form of sine, okay, and its derivative is cos. So we can apply here integration by partial fraction, okay. So we can put t as sin x and dt is cos x. Okay. So substituting t as sin x, so dt is cos x dx. Okay. So cos x dx is dt. This will be 1 minus t square. This is 1 plus 2t. So this we can expand, that is a square minus b square. So 1 minus t, 1 plus t, 1 plus 2t. Okay. So using partial fraction, 1 equal to a upon 1 minus t plus b upon 1 plus t plus 1 upon c upon 1 plus 2t. Okay. We have to find a, b and c. So cross multiplying and you will get a into 1 plus t, 1 plus 2t. C 1 minus t 1 plus t. Okay. Now here if we put t equal to minus 1, this term will be 0 and this term will be 0. So that we'll get the answer of B. Okay. So t equal to minus 1. 1 equal to B. 1 plus 1, 2. 1 minus 2 is minus 1. So B is equal to minus half. Okay. T equal to 1. So if you put t equal to 1, this and this term goes, only a remains. A, 2, 1 plus 2 into 1, 2 plus 1, 3. So a is 1 by 6. Then t equal to, here if you don't know how to find t here, you have to just put 1 plus 2t equal to 0 so that you will get the value of t. Okay, so minus half. So this term and this term gets 0. So C 1 minus of minus half. So 1 plus half is 3 by 2 and 1 minus half is half. So this is 3 by 4. So C is 4 by 3. Okay. Now we have to integrate this. So integral of a upon 1 minus t. A is 1 by 6. dt plus b is minus half 1 plus t dt plus c is 4 by 3 1 plus 2t dt. So this is very simple. You have to just put 1 minus t at some p. So your dp is minus 1p minus dp. Okay. I'll write here for 1. You can directly write, right? 1 by 6 log of 1 minus t. Okay. And we are differentiating this. So this will be 0, this will be minus 1. So we'll get here minus 7. Okay. For this it is minus half log 1 plus t. This is here you will get into 2. So 2 times 4 by 3 log 1 plus 2t plus. Now you have to put t which we had substituted. T is sine of x. Sine x 1 plus sine x 1 plus 2 sine x plus. Okay. So this is the last answer. Next question is you have to evaluate root of 1 minus root x upon 1 plus root x. Okay. So here you have to rationalize it. Okay. So 1 minus root x 1 plus root x, I am rationalizing the denominator. So multiply numerator and denominator by 1 minus root x. Okay. So this will be 1 minus root x the whole square. And this is a plus b, a minus b. So 1 square minus root x the whole square, which is 1 minus x. Correct? So this square and root gets cancelled. So it will be 1 minus root x upon 1 minus x the whole root. dx. Okay. Separating the denominators, you'll get integral 1 upon root of 1 minus x dx minus integral root x root of 1 minus x dx. Okay. Now I'll substitute 1 minus x as t. So this will be minus dx, not t. We have to substitute it as t square so that that square and root gets cancelled. Okay. So minus dx is 2t dt. Okay. So dx is minus 2t dt. Let's substitute. Dx is minus 2t dt upon root t square, which is t, right? From here you can write x also. So x is 1 minus t square. Dx is minus 2t dt. Okay. So this is minus 2t upon t square root is t. T dt. dt gets cancelled. Integral of minus 2 dt is minus 2t minus integral of minus into minus plus 2 root of 1 minus t square dt. Okay. Here you have to make use of the formula a square minus x square. Okay, I'll write it here. Integral a square minus x square is x root of x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c. Okay, this formula you have to use. So our a is 1 and x is t. Here you can substitute t. T we had taken 1 minus root of 1 minus x. So this will be x is our t plus 1 by 2 sine inverse x is t by 1 plus c. Okay. So substituting our t will get 2 I am taking inside, so this 2 gets cancelled. T is root 1 minus x root of 1 minus x the whole. T square is 1 minus x. 1 minus 1 minus x. So 1 minus 1 plus x. So it will be root x plus sine inverse t is 1 root of 1 minus x plus c. Okay.